We have the square root of 6x plus 10 is equal to 8. And then the second one that we're going to be looking at is the square root of 3x minus 5 is equal to 4. So let's go ahead and look at the first one. Let's do that one. The square root of 6x plus 10 is equal to 8. So what we're going to do, we want to, number one, we have to make sure this square root is by itself on one side, and it is. That's what we want. We will be looking at some examples where the square root is not by itself on one side and what we must do. Next, we want to get rid of the square root by raising both sides of the equation by 2. So on the left hand side, the square root and the exponent of 2 cancels out, and we're left with 6x plus 10 is equal to 8 squared, which is 64. Subtract 10 to both sides now because we're going to solve for x. And we have 6x is equal to 54. Then we divide by 6. And we have x is equal to 54 divided by 6 gives us 9. To check our work, go back to the original equation, plug in 9 for x. We have the square root of 54 plus 10. This is just checking. The square root of 54 plus 10 is the square root of 64, and the square root of 64 is 8. So that checks out. 9 is our solution. Next example. The square root of 3x minus 5 is equal to 4. We want to make sure the square root is by itself on one side, and it is. And then we're going to raise both sides of the equation by the power of 2 because the index is 2 here. So on the left-hand side, the exponent of 2 and the power of 2 cancels out, and we have 3x minus 5 is equal to 4 squared, which gives us 16. We're going to add 5 to each side. We have 3x is equal to 21. Then divide by 3 to solve for x, and x is equal to 7. Let's check to see if 7 is the solution or if 7 is an extraneous solution. So we're going to plug 7 in for x. Multiply it to 3. We have 21 minus 5. And 21 minus 5 is 16. And the square root of 16 is 4. Therefore, it checks out. This is a true statement. 7 is our solution.